Hello, welcome to you all. Today we'll be solving linear algebra from year 2022 for the ODE for the CSE maths optional PYQs. So let's go. Linear algebra. This is 2022 maths CSE. And the first question is, prove that any set of n linearly independent vectors in vector space V of dimension n constitute a basis for a V. In order to solve this question, first we need to know the definition of basis. So, what is the definition of basis? तो यहाँ पे given है कि V is a vector space. V is a vector space S is equals to, let's say, alpha 2 cn up to alpha n is basis if one S is linearly independent. दूसरा condition is this S linear combination of S is V. If these two conditions are satisfied, we can say that S is basis for V. So we will be using this to prove this. So prove that any set of n linearly independent vectors in theorem. This is definition. Fine. तो अब हम प्रूव करेंगे. तो गिवन दैट हमें गिवन है लाइक n linearly independent vectors in vector space V of dimension n constitute a basis for V. So let say S is equals to alpha 1, alpha 2, alpha n B linearly independent vectors. Fine. To prove, since the first condition is satisfied, S is linearly independent, fine. And now to prove linear combination of S is V. If we can prove this, we are done. So what is there that we need to show? Okay. So suppose S1 of beta 1, beta 2, so on up to beta n be n linearly independent basis for V. तो this implies that चूँकि ये basis हमने माना है, तो we can say that L of S1 is V, and also this condition satisfied, this condition satisfies, and linear S1 is linearly independent, and also linear combination of S1 is equals to V. So we are done. So S1 is basis. Now, since S1 is basis, तो हम क्या बोल सकते हैं कि every element ऐसे लिखते हैं, every alpha belonging to S can be written as linear combination of, can be written as, so something like this. Alpha 1 is A1 beta 1 plus A2 beta 2, so on up to इसको लिख सकते हैं A11 A12. We will be using A1 n beta n. Fine. Because it is basis, beta 1 beta 2 is basis, so we can write it as similarly A2 can be written as A21 B1 A22 B2, something like this, A2 and Bn again. So this way we can show that. So again, like alpha n can be written as an1 beta 1 an2 beta 2 so on up to ann beta n. Now we have to prove this one, L of S1. So let's go with this. Laplace linear combination of S1 is, so suppose B1 alpha 1 B2 alpha 2 so on up to Bn alpha n. We know from these equation we can substitute alpha 1 alpha 2 say alpha n. So it will become something like this. B1 alpha 1 is nothing but we can write it as something like this, summation B1 Bi A Aij alpha I beta I summation this will be J only. Summation will go from 1 to n and J will go from 1 to n. If we are not wrong with summation, I think this will be, so we can prove, we can check it as, so we for 1 alpha will go from A11 A12 yeah, that's good. So it is nothing but the linear combination of vectors beta 1 beta 2 so on up to beta n. This is nothing but linear combination of S. Linear combination of S1 and from A we know that, so indirectly we have said this L of S from A, L of S1 is A, so we can say that L of S is A. So hence what we had to prove, L of S is V, so A should be V, sorry, because it is vector V, it is vector space V. Yeah, so and also S is n linearly independent vectors, therefore S is basis for V. Very good, so we are done. So the thing was that we should know the definition, like hota kya hai basis. So the second question is, linear transformation is given, we have to find this. So I think it was one of the easiest problem in the paper. So we know that like linear transformation is nothing but A alpha plus B beta is nothing but A T alpha plus B T beta. So we have to make something like this. So we can write as 2, 4 is nothing but A times of इसके फॉर्म में लिखते हैं 1, 0 B times of 1, 1. So if you notice, A will come out to be 2, A plus 1 B plus 1 is 2, A0 B 4, तो A is equals to -2 रख दो अब, तो 2, 4 would become -2, 1, 0 plus 4, 1 comma 1, and I think 4 से 4, I think we are right. Yeah, yes, yeah, we're right. So applying transformation, transformation both side. So t2 comma 4 is minus 2 times t1 comma 0 is 4 times t1 comma 1, and we know that minus of t1 comma 0 is nothing but 1 2 3 1 2 3 4 1 comma 1 minus 3 2 8 minus 3 2 8. So it will become like this: minus 12 minus 2 minus 14 minus 12 minus 2 minus 14 8 4 4. This is minus 12 minus 2 minus 14 8 4. This will become 32 6. I think it is 26. But this 26, yeah, 26. So t2 comma 4 becomes like this. So this is answer. It was the easiest problem. So we have to solve the given system of equation by row reduced equivalent form. So we can write in the form of matrix. The Ax would be B in matrix format. So where A is nothing but 1 2 minus 1 2 3 5 minus 1 minus 3 8. B is nothing but 2 5 minus 1. Yeah, great. So now what we can do here, to solve such kind of problem, we should write first augmented matrix. Augmented matrix is nothing but matrix A augment B, where we do nothing but just write on the right hand side the column B 1 2 minus 1 2 3 5 minus 1 minus 3 8. This is augmented matrix 2 5. Augmented बस जोड़ना, augment मतलब add करना. And now what we'll do is that we will be converting A augment B into echelon form, row reduce echelon form, and then we'll be solving it. So whatever operation we'll be solving this left hand side, we'll be applying the same in the RHS augmented matrix too. Fine. So what we can do here, so in order to make row reduce method, so we'll be applying R को इसको 0 करना है. R tends to R3 plus R1 fine. R2 becomes R2 minus 2 of R1 fine. So we can make it. So it will become 0. It will become minus 1. It will become 7. This will become 0. This will become minus 1. This will become 7. And 1 2 minus 1. And also we will be applying the same here also. It will become 3. It will become 1. It will remain as it is. Okay, so you see, like, this becomes common. This wala row and this wala row become common. So we can subtract it. It will become 0. I think we are correct. We are not wrong anywhere. 4 7. R3 R1, yes, R3 को R3 minus R1, 0 sorry 1 2 minus 1 0 0 0, जस्ट घटा दिया, यहाँ से R2 है, यहाँ पे 2 आएगा. I think we are not wrong. 2 5 array, this is minus 1. This is minus 1. If we do this, it will become 1. It will also become 0. First type of mistakes जहाँ पे हम लोग माइनस छोड़ देते हैं, प्लस छोड़ देते हैं, can be disastrous in exam if we do not pay attention to such kind of things. So it is advisable that spend 1 minute extra at the end of question to verify the calculation. It actually helps to reduce the error. So you can practice this habit during a mock to get accustomed with time management, like how you manage the time with respect to these calculation and their rechecking. So it can actually yield high result, like in order to get the correct answer, and also there will be no scope for kind of mark deduction. So 1-2 मिनट की देरी सही है कि आप गलत आंसर लेके आ रहे हो. एक क्वेश्चन छूट जाए पेपर में सही है, बट जो सवाल करके आ रहे हो दैट शुड बी 100% करेक्ट. अदरवाइज़ कि मतलब हम पूरा सवाल पेपर कर रहे हैं बट और 4 क्वेश्चन लाइक 4-5 क्वेश्चन कैलकुलेशन के कारण गलत हो जा रहे हैं, तो दैट इज़ नॉट फेयर. एक क्वेश्चन छोड़ो बट 4 क्वेश्चन जो हमें आते हैं उसको पूरा सही से करें. तो दिस इज थिंग आई हैव हर्ड मेनी पीपल से, many toppers basically say. So what we can do here, so just proceeding the similar way. So यहाँ पे 1 आ जाएगा, यहाँ पे 2 आ जाएगा, and now here now यहाँ से मल्टीप्लाई कर दिया, R3 को मल्टीप्लाई कर दिया, R2 को मल्टीप्लाई किया -1 से, this will become plus minus minus. So this has become reduced in echelon form. So here we see that the rank of A is nothing but rank of A augment B less than number of variables. इसका मतलब ये हुआ कि the system of equation is consistent but it will have infinite solutions. This implies that system of equation is consistent but it will have infinite solutions. So yeah, तो अब क्या करें, like we can solve it. तो we can solve it as तो x plus 2x 2y minus z, I think we are right, x1 x2 x1 x2 minus x3, I think we're right, is 2x2 minus 7x3 is equals to I think it is 1 minus 1. तो यहाँ पे we can put any variable as some constant, some variable k or some t. So say x3 is k where k belongs to some real, then x2 will become 7k minus 1. Then again we can put it there, sorry, x1 plus 14k minus 2 minus k is equal to 2. I think we're right. तो x1 will become यहाँ से 4 है, 4 13 minus 13 की, तो इक्वेशन becomes basically, I think we are correct. x3 को हमने k डाला तो ये सब सही चल रहा था, हमने इसको माइनस से मल्टीप्लाई कर दिया था. ओके 1 2 minus 1 1 2 minus 1 1 minus 7 minus 1 2. yes, तो x3 को मैं k डाला है तो x2 will be 7k minus 7k minus 1. then x1 उसको x2 is nothing but 14 minus 2k is minus k is 2. तो 4k 13k. then so x1 is 4 minus 13k, x2 is 7 minus 7k minus 1, x3 is k, where k belongs to some real number. We are dealing with real number only. Yes, so we are done. So now we have to say, prove that like be the collection of vectors in R cube, vector space R cube, field R, this is vector space, this is field. We have already, you might have studied all these things like what is vector space, what is field in theory part. So we have to say that P is a subspace. So if you look this, P is nothing but kind of null space, nullity, null space of this equation. So it will be like that: x1 by x1, P would be x, y, z, such that x minus y minus z is equal to 0, 2x minus y plus z equals to 0. ठीक है. So what we can do, say it is 1, say it is 2. If we add, to it will 1 plus 2 will become, so 3x minus 2 is equals to 0. So 3x plus 3x equals to 2y. So we can substitute it anywhere. So if we put it in 1, so it will become x minus y is 3x by 2, putting 4 in 1, x minus y is equal to 3x by 2 minus z. So z will become minus x by 2. I think we are right. So the entire P will become, P is, x is nothing but x, y is nothing but 3x by 2, z is nothing but half. It can also be written as x 1 3 by 2 minus half. Yes, so we are done. So this is the P vector which satisfies the given conditions, where x is a real number. Now we have to prove that P is a subspace. So what for subspace, like P alpha 1 and alpha 2 is element of P, and A and B is element of field. Then if A alpha 1 plus B alpha 2 is element of P, then P is a subspace. Space. So we'll be doing the same thing. So what we can do here, P is subspace. So what we'll be doing here, so see, alpha x1, this whole term, 1 x1 1 3/2 minus half, and x2 1 3/2 minus half will be element of P, and AB belongs to R field. Now A x1 1 3/2 half plus B x2 1 3/2 3/2 half will become A x1 plus B x2 1/3 1 3/2 minus half. Here ax1 plus bx2 will be element of R. Therefore ax1 therefore this entire element, say this is P, this is L. So therefore L is element of S. Therefore S is a subspace. So we are done. S is a subspace. क्योंकि ये वाला पार्ट रियल नंबर को बिलोंग करता है, and we have saw that we had seen that, like, if x is element of R, then this entire expression x into this wala expression becomes the element of P. So that's why here this is element of R. That's why जो हमने L वाला expression लिखा था, ये entire expression will become an element of S. So S is a subspace. Now what do you have to do? What do you have to say? Basis and dimension of P. So dimension of S, dimension of P. Yes. So P is nothing but x 1 half 1 3/2 minus half. Yes. Where here is a vector where 1/1 3/2 minus half is linearly independent vector, and linear span basically x x say and let P1 belongs to P. So we can say that P1 is equals to x1 times 1 3/2. बस हमने बेसिस की डेफिनेशन हम वहीं प्रूव कर रहे हैं जो हमने पहले भी प्रूव करा था. इज एलिमेंट ऑफ S. Element is linear combination of 1/1 3/2 and half. So this implies that P1 is also element of 1 3 by 2 minus half. This implies that P is a subset of Laplace transformation of 1 3 by 2 half, and we know that इसका linear combination भी also linear combination of 1 3 by 2 minus half is subset of P from A from B. We can see that 1 3 by 2 half is P. Therefore 1 3 by 2 minus half is basis of P, and there is only one element. So dimension of this entire expression 1 3 by 2 minus half is there is only one element, so dimension is 1. हमने ये प्रूव करना पड़ा कि लाइक ये लिनियरली इंडिपेंडेंट है, जो कि हमने दिखाया था. बेसिस प्रूव करने के लिए हमने पहले भी दिखाया था कि लाइक देयर इज ओनली 2 कंडीशन कि एलिमेंट वेक्टर्स इंडिपेंडेंट होने चाहिए, एंड आल्सो linear combination of the vectors should be equals to the vector space. So just we had shown them, like we had showed only that thing. तो हमने ये दिखा दिया कि ये वाला टर्म है, और हमें पता है कि लाइक ये इसका लीनियर कॉम्बिनेशन विल बी सबसेट ऑफ P. P is nothing but this term, and we have seen that any combination of these expression will satisfy P. That's why this linear combination will be a subset of P. So from A and B हम लोग कह सकते हैं कि ये इसका सबसेट है, ये इसका सबसेट है. This will be only possible when both of them are equal from A and B. So we are done. I hope you understand. So the fourth question. So find a linear map of which rotates each vector of R square, like in real space, in xy plane or any plane, like it's a real plane, by angle theta. Prove that at theta pi by 2 t has no eigenvalue. So we can assume it as xy plane. This is R square is nothing but xy plane, a real plane. ठीक है. तो we have to show that find a linear map T से R square से R square तक. तो let हमने मान ही लिया कि ये जो प्लेन है वो xy R square जो वेक्टर स्पेस है वो xy प्लेन का है. तो let u is equals to 1,0 sorry x yeah, and v is equals to 0,1 be vectors. तो ये बेसिकली हुआ क्या, ये x एक्सेस हो गया, ये y एक्सेस हो गया. x इसका 1 है और y 0 है. बी वेक्टर्स लीनियर मैप है. तो विच रोटेट its vector by angle theta. Prove that theta for theta is equal to pi by 2. There is no eigenvalues in R. So इसका मॉडुलस 1 है. तो इसको हमने रोटेट कर दिया थीटा से. इसको रोटेट कर दिया, क्या हो जाएगा, ये 90 तो पहले से ही था, तो ये हो जाएगा थीटा. तो हमें पता है कि लाइक पैरामीट्रिक में क्या होता है, ये इसका कोऑर्डिनेट हो जाएगा एक्स कॉस थीटा, ये एक्स कॉस थीटा, ये एक्स साइन थीटा. तो ये एक्स तो 1 ही है, लाइक ये वाला डिस्टेंस तो 1 है, क्योंकि यू वेक्टर हैज मॉडुलस मैग्नीट्यूड बेसिकली 1, so it will become cos theta sin theta. So it will become something like this. Here ये वाला डिस्टेंस तो cos theta. I think we are not wrong here. It will be 390 minus theta ये पूरा 9, ये थीटा नहीं होगा, ये थीटा है, ये 90 है, और ये 90 माइनस थीटा है, तो दिस विल बिकम थीटा। यस, तो दिस विल बिकम 1 cos थीटा 1 sin थीटा, ये वाला डिस्टेंस sin थीटा हो गया। तो ये sin थीटा चूँकि नेगेटिव में है तो इसका कोऑर्डिनेट रहेगा माइनस sin थीटा, और ये ऊपर cos थीटा क्योंकि x ये नेगेटिव को x एक्सिस में है तो ये माइनस sin थीटा हो जाएगा। ये ऊपर जो है ये cos थीटा ये प्लस y में है, दैट्स व्हाई इट्स कोऑर्डिनेट विल बी माइनस sin थीटा प्लस cos थीटा। तो सो आफ्टर rotation these vectors would be the vector after rotation by angle theta, these vectors would be cos theta, sin theta and minus sin theta, cos theta। आई होप ठीक ही चल रहा है, लाइक कुछ साइन गलती नहीं किया मैंने। यस यस यस। सो व्हाट यू टू शो लीनियर मेथड एंड थीटा बाय एंगल प्रूव कर, ठीक है। सो द वेक्टर द ट्रांसफॉर्मेशन विल बिकम transformation of u and v will become ये cos थीटा sin थीटा, क्योंकि हमने मान रखा था कि ये u ये है u v है, तो इस पर ट्रांसफॉर्मेशन से हमारा u ये आ गया v ये आ गया। मानना यहाँ पे सिंपली आसान पड़ गया, लाइक अब और भी कुछ और मान सकते थे बट इट विल मेक आवर लाइफ मोर कॉम्प्लेक्स। तो एक्स वाई कोऑर्डिनेट मान के आसान हो गया चीज़ें। सो दिस बिकम ट्रांसफॉर्मेशन, सो दिस इज द ट्रांसफॉर्मेशन दैट वी गॉट। सो लीनियर मैप विच रोटेटेड मैग्नेट बाय थीटा, ठीक है। नाउ प्रूव दैट एट फॉर थीटा इक्वल टू पाई बाय 2 देयर इज नो आइगन वैल्यू। सो नाउ थीटा इज इक्वल टू पाई बाय 2, t is cos 90 0, sin 1 sin 0 cos 90 0। तो कैरेक्टरिस्टिक आइगन वैल्यू निकालने के लिए कैरेक्टरिस्टिक इक्वेशन निकालना पड़ेगा। कैरेक्टरिस्टिक इक्वेशन इज a माइनस लैम्डा का मॉडुलस। तो a माइनस लैम्डा इज माइनस लैम्डा माइनस 1 माइनस लैम्डा इज इक्वल टू 0। a minus lambda I, this will become lambda square plus 1 is equals to 0. This is nothing but plus minus iota. So we are done. तो बोल एक्चुअली इमेजिनरी है, विच इज नॉट रियल। हाँ वही करना, नो विच इज नॉट रियल आइगन वैल्यू। अदर्स प्रूफ डन। सो थैंक यू ऑल।